Russell Tackett with HydraForce, the Electronic Sales and Application Engineer. It's about part 3 of the series, the ECU 0809 control code creation. This version is part 3, the service tool creation. So what we've done in part 1 is we've walked through the steps to create a backbone file that ultimately will take an analog input and drive 2 PWM output coils. So that we did the backbone file, how to create the backbone file in version 1 or part 1. In part 2, we looked at the code that's required to take the backbone file and actually drive a coil out of the outputs. Then part 3, we're going to spend a little bit of time in the service tool to talk about how we get this out to the field and maintenance people could somewhat like tune the system. So if we back all the way back into Backbone 1, so kind of review a little bit of part 1. Backbone 1, for the object dictionary, CAN 1, we saw variables that we wanted to be able to monitor or modify. The parameter was something that we look at after power cycle. Valve 1 system goes into a RAM variable, so it's something that will change on a power cycle, so it doesn't actually hold its values. But we set up all these values that we wanted to use to monitor our system. Again, joint 1, signal minimum, signal center, signal max, deadband center, deadband error. 1, tuning both coil 1 and 2, current minimum, current maximum. The system looking at system voltage, 5-volt reference, internal temp variables. Then at RAM, I wanted to monitor what was going on with the joystick in millivolts. And I want to monitor what's going on with current on both the coils. I'd taken this and we had done a save configuration and a mod file that I called HF service mod. Okay, if we open up HF Impulse, this is the opening screen we get. Your process along the side here may not be as much depending on the modules you have installed, but I want to do a file, new, and the ECU XXXX, and the ECU XXXX. It's going to be the option to either launch this converter, backbone to HF impulse converter, or ECU XXXX interface. So we're going to install, or we're going to launch the converter. At the top is OK, open a mod file. So if I do that, go search for the mod file that we created, and this is where I have mine sitting on my computer. It's a movie clip. I don't know why the computers just interpret a mod file as a movie clip, but M-O-D, I'm sorry. Open. We can then look at the settings. We can look at control parameters. So these are the parameters that we wanted to modify or wanted to be able to modify live. Okay. Monitor parameters for defaults, security. So add this in here. We can export the configuration. .icf file. So up there it says you want to replace it. Sure. I can close this file. Yes. Probably this. I just always wanted to do it. I'll go ahead and open up my HF Impulse program again. Their screen. So give it a second here. Okay, we'll bring it back over. So now I want to do a file open, and I want to find that ICF file that we've just created, and hit open. Now I see that the format's changed a little bit. Okay, so this is the type we gave it, HF Service Tool. This is the ECU 0809, CAN Node 1, baud rate 250, so on and so forth. Parameters, we see that, okay, these are the parameters that we were going to control parameters, so these are ones that we can modify, and these are ones that we just need to monitor. So monitor. Active if there are any on the network, fault-free communication. So I'm going ahead, I'm using, there's 2 different USB CAN adapters you can use for this. You can use the Kvaser, or Peak Systems make a PCAN to USB adapter. So right now my system, I have my capacitor hooked up to my ECU controller. I'll use my peak to monitor the controller. You cannot use the USB adapter to monitor both the service tool and the ECU at the same time. So selecting peak, I'm going to hit start and finds my controller with a CAN node ID of 1 and a codesys ID of 2. Okay. For production capability, whatever, you can just open a file and download the bin file from this screen. When you get these out of the box, their initial ID is 127, 126. So you see mine is 1 and 2. So I can come over here and I can log on. We see the one line right now. If I had any errors, it would be in the lower left-hand corner. But it's okay. My ECU is showing a value of 500 and 4500, but the value of this ICF file is just showing 0 and 500. So I'm going to change these to 500 and 4500. Then I can match those values to the controller. Okay, so we can set my joystick right now is 2540. We come over here and look at the codesys. Okay. Come to our joystick. So our stick has a value 2540. I change the joystick. Get 40. Okay, so I'm entering it here, and I've also got a value of 382 milliamps going to coil A. 302 milliamps. Easy way without having to have your service people study your codesys code. An easy way to get values out of codesys and into their hands to be able to modify. They can come over here and say, okay, I don't want my signal minimum to be at 500 millivolts or half a volt. I want it to be at 450. Change that, flash parameters. Something that's really, really valuable, that you'll find valuable to use. You've got variables that you can go and monitor anything that you're monitoring. So I could signal, I could look at 1, I could look at coil 2. We can do charting to start charting. So you change my analog voltage, the real value of it up here, 1980. Then we can put, what current is going on as far as just a raw value, 679. You could say, okay, I want to stop charting, export for data. Would you like to export it to? Sure, this is fine. So remember what that is. Call it test.sv, my ECU1 section. Okay. Then my Excel. Open that up. H presentations. One called test, CSV. And this is all the data that we have in that section. So at time 10:57, which, that's the time of my computer, the value of data 1 was 1900, value of data 3 was 450. So then you can make charts and graphs and help shoot your system that way. So nice, no additional charge. We talked about parameters. Had faults in the section. You can monitor those here. Fault history, what's going on with that, including the SPN number. Communicating, we talked about access the controller, and then chart recorder. All about how valuable it is to have 2 different USB to CAN converters, 2 different. So I can talk to one converter and the other, so I can monitor my code assist code and this service tool also. But once again, the service tool is great for tuning the system in the field where someone doesn't need your code. If you don't want to give the code out, kind of have some intellectual property security, not being able to share that code, this service tool is a great way to perform that function. Once, my name is Russell Tackett with HydraForce. I'm the Electronic Sales and Application Engineer, and this is part 3 how to create a service tool for ECU 0809 controller. Thank you.